Hello everyone, I'm Professor Diwa, and welcome to a math video on the algebra of functions. Our objectives are to add, subtract, multiply, and divide functions, construct composite functions. Alright, so let's get started. First, we have the algebra of functions. It states here, let f and g be functions. New functions from f and g are defined as follows. Number 1, sum. F plus g of x equals f of x plus g of x. Number 2, difference. F minus g of x equals f of x minus g of x. Number 3, product. F times g of x equals f of x times g of x. Number 4, quotient. F over g of x equals f of x divided by g of x, where g of x is not equal to 0. In the next example, I'll show you how we apply these rules to our newly defined functions. For example number 1, for f of x equals x minus 1 and g of x equals 2x minus 3, find the following. For part A, we need to find f plus g of x. Here we'll need to apply the sum rule, so this is equal to f of x plus g of x. All we need to do here is substitute x minus 1 for f of x and substitute 2x minus 3 for g of x. We get x minus 1 plus 2x minus 3, and then we can simplify by combining like terms. X plus 2x is 3x, and then minus 1 and minus 3 is minus 4. So the final result is 3x minus 4. Moving on to part B, we have f minus g of x. We apply the difference rule, which is just f of x minus g of x. Again, we just substitute x minus 1 for f of x, and we substitute 2x minus 3 for g of x. We get x minus 1 minus parentheses 2x minus 3. From here, we go ahead and distribute the negative inside the parentheses to the 2x minus 3, and then bring down the other terms. So we get x minus 1 minus 2x plus 3. Next, we simplify by combining like terms. X minus 2x is negative x, minus 1 plus 3 is plus 2. So the final result is negative x plus 2. Moving on to part C, we need to find f times g of x. For this function, we need to apply the product rule, so this is equal to f of x times g of x. Again, we just substitute in the values for f of x and g of x. We get parentheses x minus 1 times parentheses 2x minus 3. Next, we multiply the two binomials together by using FOIL. Multiplying the first terms together, x times 2x is 2x squared. Multiplying the outer terms together, x times minus 3 is minus 3x. Multiplying the inner terms together, we have negative 1 times 2x is negative 2x, and then negative 1 times negative 3 is positive 3. The result is 2x squared minus 3x minus 2x plus 3. Next, we combine like terms with the minus 3x and the minus 2x, which is negative 5x. The final result is 2x squared minus 5x plus 3. Next, we move on to part D. We need to find f over g of x. We apply the quotient rule for this function, so this is equal to f of x divided by g of x. Again, we just substitute in the values for each function. We get x minus 1 over 2x minus 3. We can't simplify this any further, so this is our final answer. Next, we have a practice problem. For f of x equals x plus 2 and g of x equals 3x plus 5, find the following. For part A, we have f plus g of x. For part B, we have f minus g of x. For part C, f times g of x. For part D, f over g of x. Alright, so go ahead and pause the video, work out each problem, and then check back with the video to see the solutions. Alright, so let's go over the solutions. For part A, we just take f of x and add g of x together. We get x plus 2 plus 3x plus 5. After simplifying, we get the final result is 4x plus 7. For part B, we just subtract g of x from f of x. We get x plus 2 minus parentheses 3x plus 5. First, we distribute the negative inside the parentheses, and then we bring down all the other terms. We get x plus 2 minus 3x minus 5. After simplifying, the final result is negative 2x minus 3. For part C, we just multiply together f of x and g of x. So we get parentheses x plus 2 times parentheses 3x plus 5. After doing the multiplication, the result is 3x squared plus 5x plus 6x plus 10. Next, we add together 5x and 6x, which is 11x, and then we bring down all the other terms. So the final result is 3x squared plus 11x plus 10. For part D, we just take f of x and divide it by g of x. We get x plus 2 over 3x plus 5, which is the final answer. Next, we have composition of functions. The composite functions f composed with g, the composition of f and g, is defined as f composed of g of x is equal to f of g of x. This equation is telling us that f composed of g of x is the same thing as taking g of x and substituting it into the first function f. So essentially, function composition is just substitution. For example number 2, given f of x equals 3x and g of x equals 1 plus x squared, find f composed of g of 5 and f composed of g of x. Starting with f composed of g of 5, this is equal to f of g of 5. So what we could do first is find g of 5. We just take 5 and plug it into the function g for x. We get g of 5 is equal to 1 plus 5 squared. Next, we simplify. 5 squared is 25, and then we bring down the 1. 1 plus 25 is 26. So we have g of 5 is equal to 26. Next, we take the value of 26 and substitute it into the function f. This gives us f of 26. To find f of 26, we just take 26 and substitute it in for x in the function f. We get f of 26 is equal to 3 times 26, which is 78. So the composition of f and g of 5 is equal to 78. Next, we need to find the composition of f and g of x. According to our rule, this is equal to f of g of x. So what we need to do is substitute in 1 plus x squared for g of x. We get f of 1 plus x squared. Next, we need to take 1 plus x squared and substitute it in for x in the function g. This gives us 3 times the parentheses, 1 plus x squared. Next, we need to simplify this by distributing the 3 inside the parentheses to the 1 plus x squared. The result is 3 plus 3x squared, so f composed of g of x is equal to 3 plus 3x squared. Next, we have a practice problem. Given f of x equals 3x and g of x equals 1 plus x squared, find the composition of g of f of 5 and g of f of x. Alright, so go ahead and pause the video, try out this problem, and then check back with the video to see the solutions. Alright, so let's go over the solutions. First, we need to find the composition of g of f of 5. This is equal to g of f of 5. First, we need to find f of 5. So we take 5 and substitute it into the function f. We get f of 5 is equal to 3 times 5, which is 15. So next, we need to find g of 15. We take 15 and substitute it into the function g. G of 15 is equal to 1 plus 15 squared. 15 squared is 225, and then we bring down the 1. 1 plus 225 is 226. So the composition of g of f of 5 is equal to 226. Next, we need to find the composition of g of f of x. This is equal to g of f of x. We just need to substitute in 3x for f of x. We get g of 3x, and then we need to substitute 3x in for x in the function g. This is 1 plus parentheses 3x squared. Next, we simplify by squaring the 3x. The result is 1 plus 9x squared. So the composition of g of f of x is equal to 1 plus 9x squared. For example number 3, find f and g such that h of x equals the composition of f of g of x. Given, for part A, we have h of x equals 3x minus 5. So h of x is equal to the composition of f of g of x, and by our definition, we also know that this is equal to f of g of x. So what we need to do here is just identify the function f of x and g of x such that when we do the composition of f and g of x, we get the equation for h of x. Notice here that I highlighted the 3x in red and the minus 5 in blue. Whenever we do the composition of f and g of x, we replace the x from the function f with the value of g of x. So if we take a look at the 3x minus 5, the 3x in red represents our function g of x. So before we substituted in the 3x there, originally there was an x. So that means the equation for f of x is x minus 5. Now if we check the composition, we take g of x, which is 3x, substitute it in for x in the function f, which would result in 3x minus 5, which is the equation for h of x. So everything works out, and the final answer is just f of x equals x minus 5, and g of x equals 3x. Let's go ahead and try another one. For part B, we have h of x equals parentheses 7x plus 3 squared. So again, we need to find two functions, f of x and g of x, such that when we do the composition f composed of g of x, we get the function for h of x. So there's actually more than one way to do this problem, but the first way I'm going to start off by making g of x 7x. So notice here in the function h of x, I highlighted 7x in red and the rest of the function in blue. Again, 7x is going to be my g of x. This means before we substituted in the 7x, there used to be an x there. So my function for f of x in blue should be parentheses x plus 3 squared. Now if we check the composition of f and g of x, we take 7x, substitute it in for x in the function f, and we get parentheses 7x plus 3 squared, which is the equation for h of x. So everything works out. So the final answer is f of x equals parentheses x plus 3 squared, and g of x equals 7x. Next, let's go over an alternative way to do this problem. So again, I have h of x equals parentheses 7x plus 3 squared, but on the inside of the parentheses, I highlighted the 7x plus 3 in red. The 7x plus 3 in red is going to represent my g of x. Now before we substituted in the 7x plus 3, there used to be an x there. So the function for f of x in blue is x squared. Now if we do the composition of f of x and g of x, we take 7x plus 3, substitute it in for x in the function f, and this results in parentheses 7x plus 3 squared, which is the equation for h of x. So everything works out, and our final answer would be f of x equals x squared, and g of x equals 7x plus 3. Next, we have a practice problem. Find f and g such that h of x equals f composed of g of x, given, for part A, we have h of x equals 6 over 5x minus 2, and for part B, we have h of x equals the square root of 9x plus 1. Alright, so go ahead and pause the video, take your time working out this problem, and then check back with the video to see the solutions. Also remember there's more than one way to do this problem, so you can have multiple solutions. Alright, so let's go over the solutions. For part A, you could have gotten f of x equals 6 over x, and your g of x could be 5x minus 2. You can see here, if we do the composition of f and g of x, we take 5x minus 2, plug it in for x in the function f, and then we get the equation for h of x. We could also have f of x equals 6 over x minus 2, and g of x equals 5x. If we do the composition of f and g of x, we take 5x, substitute it in for x in the function f, and then we get the equation for h of x. So this works out as well. For part b, I have f of x equals the square root of x, and g of x equals 9x plus 1. If we do the composition of f and g, we take 9x plus 1, substitute it in for x in the function f, and the result is the equation for h of x. So this one works out. We could also use the function f of x equals the square root of x plus 1, and g of x equals 9x. If we compose the function f and g, we take 9x and substitute it in for x in the function g. The result will be the equation for h of x. So this one also works. For example number 4, if f of x equals 5x, g of x equals x minus 2, and h of x equals the square root of x, write each function as a composition using two of the given functions. For part A, we have capital F of x equals the square root of x minus 2. So what we need to do here is figure out which two functions composition results in the function capital F of x. For capital F of x, you can see here we need a function that has a square root. We also need x minus 2. So the two functions we're going to use is g of x and h of x. Now there's two different ways that we could perform this composition. However, only one of them would be correct. So the first composition I'm going to try is g composed of h of x. If we do the composition, we take h of x, which is the square root of x, substitute it in for x in the function g. This results in the square root of x minus 2. You can see here that this does not equal the function capital F of x. So next we'll try the second composition, h composed with g of x. So we take g of x, which is x minus 2, substitute it in for x for the function h. We get the square root of x minus 2, which is the function capital F of x. So the final answer is h composed of g of x. Moving on to part B, we have capital G of x equals 5x minus 2. Again, we need to figure out which two functions composition results in the function capital G of x. In order to create this function, it looks like we need a 5x and an x minus 2. So we're going to use the two functions f of x and g of x. Starting with f composed of g of x, we take g of x, which is x minus 2, substitute it in for x in the function f. We get 5 times the parentheses, x minus 2. Next, we distribute the 5 inside the parentheses to the x and the minus 2. We get 5x minus 10. You can see here that this does not result in the function capital G of x, so this is not going to be our solution. Next, we try the composition g composed with f of x. We start by taking f of x, which is 5x, substitute it in for x in the function g. We get 5x minus 2, which is the same as our function capital G of x. So our final answer is g composed of f of x. Next, we have a practice problem. If f of x equals 3x, g of x equals x minus 4, and h of x equals the absolute value of x, write each function as a composition using two of the given functions. For part A, we have capital F of x equals the absolute value of x minus 4. For part B, we have capital G of x equals 3x minus 4. Okay, so go ahead and pause the video, try out these problems, and check back with the video to see the answers. Alright, so let's go over the answers. For part A, the answer is h composed of g of x. If we take g of x, which is x minus 4, substitute it in for x in the function h, we get the absolute value of x minus 4, which is the function capital F of x. For part B, the answer is g composed of f of x. If we take the function f of x, which is 3x, and substitute that in for x in the function g, we get 3x minus 4, which is the function capital G of x. Alright, well this is the end of our video. Thank you very much for watching. I'm Professor Diwa, and I'll see you in the next one.